Guys, this is AAT, section 2.5, graphing absolute functions. So the function f of x equals the absolute value of x is the absolute value function. The highest or lowest points on the graph of an absolute value function is called the vertex. The graph of an absolute value function is in this form. Notice it's very similar to the form we're used to with the parabola, where h and k are the vertex. Notice it's the opposite sign of what you see with x, same sign what's on the outside to go with your y. The slope on the right side of the vertex is this number a. The slope on the left side of the vertex is the opposite of a. So to graph it, first thing we're going to do is look and see what's with x and make sure it's the opposite sign, which is of course a 0. There's no h there. And k is the same sign as you see here, which is -3. Your slope is the number that comes up here in front, which is 1. And since it's going to go both ways, it's going to be 1 and -1. And we're going to start with this vertex, 0 to -3, and go up 1 over 1, up 1 over 1, up 1 over 1, and know this shape is going to be a V shaped. It's going to be up if A is a positive number, and it's going to go down if our A is less than 0, the number in front of that X here. So there's our first one. So our second one. Look at the vertex, opposite sign of what's with X is 2. Same sign of what's on the outside is 1. Again, our A value is 1, which means our slope is up and down, positive and -1, excuse me. This again is going to be an upward facing V because our A value is positive. So we go to the point 2, 1 for our vertex and use that slope. Up 1 over 1, up 1 over 1, up 1 over 1, up 1 back 1, up 1 back 1, up 1 back 1, and so forth. Remember, you can always check with like the y-intercept. This is the point 0, 3. And if I plug in 0 here, 0 minus 2, the absolute value of -2 is 2. And 2 plus 1 would be 3. So 0, 3. I know I've graphed it right. Okay, this one. Notice this one has an A value that is negative. So our slope is going to be -2 and +2, meaning it's going to be a downward facing V. Our vertex, opposite sign of what you see with X, is 1. Same side on the outside is 3. So we start at the point 1, 3. And then we're going to use the slope of 2, but make sure we're going down 2 over 1. Down 2 over 1. Down 2 over 1. Down 2 back 1. Down 2 back 1, and so forth. And we get that V on either side. Nice job. Okay, so let's flip on over on the back side here. We're going to graph each of the following, determine the domain, range, vertex, and the axis of symmetry. So we'll go a little further with it this time. So why don't you start out, pause the video here, and graph this one. All right, so your graph should have looked like this. Your vertex, opposite sign of what's with X, same sign that's on the outside, -1, down 4. Your slope, upwards facing, up 2 over 1, up 2 over 1, and up 2 back 1 to get the negative slope on the other side. Now, for domain and range, domain is all the values of X that are possible. So since this goes forever in both directions, any X I put in will work. Any X I can fill in there. So our domain, we could call that all real numbers, or in interval notation, that means it goes from -infinity to infinity. All numbers. Our range, on the other hand, are the y values. Well, the lowest this goes is down here to -4 if we're looking at the y values. And then we have y values going up. All of these have defined points, and they're going to go up and up for infinity. No y values below -4. So the range is that y is always greater than or equal to -4. And in interval notation, that means close bracket from -4 to infinity. It also asks for the axis of symmetry. Just like with parabolas, the axis of symmetry is the little line that divides it in half. This is a vertical line, and its x equals, because it's vertical, -1. So axis of symmetry, x equals -1. Okay, so this one's a little different. We got a fraction for the a, but vertex, same way. It's opposite sign, 2, 3. It faces down because it's a -1/2 for the slope. So our a value is -1/2. So start at 2, 3. And we're going to go down 1 over 2, down 1, back 2. I'm going to run out of space on the right side, but down 1, back 2 again here. So I really should use a ruler on these. This and this makes it a lot wider when it's got a fraction there as our a value. Okay, so there's the graph. The domain, again, is going to be all real numbers. You can write it this way, or as interval notation from -infinity to infinity. Our range is just from 1, 2, 3 down are the possible y values. So that would go from -infinity down here and stop stop at -3, and that's closed. Okay, so this last one's a little weird. It's got a number in front of that x and then another number. So on this one, since we want it in this form, y equals a, x minus h plus k, we really need to get that 4 out of the way. So just like we factor a GCF out, we can factor a 4 out of this whole thing. If I have that -1/4 and I pull a 4 out, and I can actually pull it all the way out of the absolute value because the absolute value of 4 is still 4. And I'm left in the parentheses or in the absolute value with the x plus 1, because 4 times x is 4x. Again, I can pull that out because the absolute value of 4 is just 4 plus 2. And then I get -1/4 times 4, which is -1 times the absolute value of x plus 1 plus 2. So now it looks like what we're used to. So the vertex is -1, 2. Our a value is 1. It's a downward facing, so it's actually -1 plus or minus 1 is our slope. So -1, 1, 2. Slope of 1, but we're going down 1, 1, 1, 1, 1, 1, both directions. Remember, you can always check by just plugging a point in anywhere. Any point that you have, plug it into the original problem and make sure you're looking correct. Now, to go back up at the top, it says to also find the domain and range, the axis of symmetry, and intervals where it's increasing and decreasing. So we didn't do all of that. This one we have domain and range, found the axis of symmetry. So intervals where it's increasing and decreasing. This graph is increasing all the way in here. So we would say that it's increasing on the interval from -1, we're looking at x values, to infinity. It's just going to keep on increasing forever after -1. So -1 to infinity. And then it's decreasing all the way over here from -infinity to -1. Now I really should make it an open parentheses because it's not increasing or decreasing when it gets to -1. It's changing between the two. So for this one, first of all, let's find that axis of symmetry again. The axis of symmetry is where x is positive 2. So axis of symmetry, x equals 2. It's increasing on the left side this time. From -infinity, we're looking at the x's until we get to 2. So -infinity to 2. It's decreasing on the right side from 2 to infinity. And then on this last one, the axis of symmetry is at -1. X equals -1. It's increasing until we get to -1, so negative infinity to -1, and it's decreasing from -1 to infinity. Okay, there was one more little problem I wanted to show you before we move on, because you might come across these as well, is what happens if it's a x equals instead of a y equals, like this. In this situation, just in case you see that somewhere, just like the parabola, if x equals instead of y equals, it's going to be a sideways facing. If a is positive, it opens to the right. If a is negative, it opens to the left. So here, my vertex would normally be 1, 3, but here the x value is going to be the 3, and the y value is going to be the 1. So 3, 1 gives us our vertex. And then, instead of going up 2 over 1 with this a, we're going to go up 1 and over 2. But a lot of times the easiest thing to do is just plug in a couple points after that. So I know I'm going to open to the right, so why not plug in, I had x was 3, plug in x was 4, or x was 2, or x was -1, and see what's happening. If I plug in x is 4, I get, y is 4, because I'm plugging in these y values that go as I'm leaving here. If I plug in y is 4, I'm going to get 3 times 2 is 6, plus 3 is 9. So at the point where x is 9, y is up at 4. But then I notice, since it's an absolute value, I would have gotten the same value on the other side. If I plug in y is 2, I get 2 times 2 plus 3 is 5. So when y is 2, x is 5, and it's going to match it on the other side. So this is also symmetric. Our slope is now up 1 over 2. So it's actually flipping this value for the slope in both directions. So just a good little thing to look at, how it's changed if your x and y are switched. A little different. The whole thing's turned sideways. And if the 2 was negative, it'd go that direction.